Welcome to the third talk. I have the pleasure of introducing two colleagues from my own project here at TNG. And I'll start with Max. I hope the spotlight function works for a change properly. So Max studied physics, is at TNG for 5 years now, is principal consultant at TNG these days. And he has many expertise, but he's, for example, one of our leading experts on Apache Flink. So if you have any random questions about that, he's definitely the person to talk to. And our second speaker today is Maxim Stykow, who joined TNG not too long ago. Before that, he did a PhD in mathematics. And as a fun fact, if you ever want to know anything about garlic farming, definitely the one person to speak to. Maxim introduced the AWS CDK into our project, and that's going to be part of the talk today. So I'm really looking forward to that. And if you're interested in more details about the project, Max Bode will actually later give a talk with Josef Viehhauser, where you can learn more about that. It's on the same track, I think, the final talk today. Maybe Max can clarify that.
Yeah, that's right.
And now some brief technical things. We have two Q&A main ways, so you can use the Zoom Q&A tool. The two speakers, when they're not speaking themselves, will try to keep an eye out for that. There's also the Slack channel of track 4, where you can ask questions that can even be asked later, answered later after the talk, or if your question isn't answered yet, you can ping them there as well. And with that, let's hand over to Max and Maxim, and I'm looking forward to an interesting talk.
Sure, thanks for the nice introduction, Arvid. So let's dive right into this. What I'm doing here on the command line is interact with AWS, so the Amazon Web Services public cloud. And I can do some commands here. So I'm interacting with S3, the simple storage service, which is just object storage. And I can create something called a bucket, which is the place where you can store your objects or files, casually speaking. Big Tech Day Virtual, let's call it. And I can interact with the cloud. I can create a bucket. I can put some files in there. So let's create something into some file. And then we can actually upload this to the cloud. So we take this file that I've just created with some important content, and we can put this actually in the bucket just via the command line. And then we can check out that, yeah, this has really happened. So I'm looking now at the management UI of Amazon Web Services and looking for the newly created bucket here.
Maxi, can you zoom in a little bit, please, in your browser?
That's a great idea, Patrick. Does it work better now? Yeah. So what we now see here, that actually this very important file with important content has arrived in the cloud already. And if that doesn't impress you so far, you're either a cloud veteran or you're right, because it's just files, but there's a lot of other stuff possible on Amazon Web Services. So for example, if you come from a more traditional software development background, maybe you know the days of waiting for days or weeks or even months for some virtual VMs that have to be provisioned. I've just made a small command to start a virtual machine. And it's just so easy. I can go over here to the service called EC2, Elastic Cloud Compute. And I see, by the way, there's a bunch of instances running here because this is our TNG internal AWS playground, where every TNG employee can easily get access and play with and learn about public cloud services. So our newly started machine, you can see here the date, it is just initializing, but probably I can already connect even either with an SSH key that was uploaded earlier, or I can even connect here in the browser. So appreciate that we are in the cloud now, right? And of course, these are just two very simple examples of how you can use cloud services. There are many more solutions that are interesting. Our talk today deals with how you can interact with all these powerful cloud services. And we propose that there's actually a hierarchy on how you can interact with these services and how you can deploy your applications into the cloud. And let's start at the lowest level. The lowest level is what we call imperative machine language. So it's machine language in a sense that these are very low-level commands. These are, I mean, what you saw earlier is a command like tell the service EC2 to run an instance, or tell the service S3 to copy a file from A to B. So these commands can very conceivably put into larger scripts that can bootstrap even large infrastructures, but still they are very, very low level. And of course, these types of APIs and these types of CLI interfaces are available for all the large public cloud providers, not only Amazon, but also Microsoft, Google, and others. But as I said, it's necessary to build custom scripts around these commands in order to lead to more complicated or interesting infrastructures. And custom built scripts like these tend to be very fragile. And so there's something to be improved upon that, right, Maxim?
Correct. Can you guys hear me?
Yes.
Very good. So hello again from me as well. I'm Maxim, and I'm going to take it up from what Max was just talking about. He was talking about imperative machine languages. And so, of course, this talk is about the evolution of infrastructure as code. So the next step from what Max has shown you by playing around on the command line is what we call declarative machine languages. So what this means is that we're going to, instead of writing line-by-line code on some command line and execute it, we're going to have one big, you can think of it as a template file. And this template file will be processed according to a declaration. So we're going to specify the state that we want to have at the end. And instead of running code line by line, we're going to just pass this declaration over to, for example, AWS or Google Cloud Platform, and let the platform think about how to actually provision this structure. All major cloud providers have this. So as you can see here on my slide, AWS calls the service CloudFormation, Azure calls it the Resource Manager, and Google calls it the Cloud Deployment Manager. So what you do is you basically pass over YAML or JSON files, and in those YAML and JSON files, you write what's the state of the application that you wish to have at the end, and then the service will take over and deploy this for you. To give you an example, I've got a picture here of something that we could build and something we will build as part of this talk over and over again. So let's go through this in a little bit more detail, because this is going to be the main application that we will be spending the rest of our talk with. So a user arrives at what we call an API gateway, which basically you can think of an endpoint that gets called in, for example, your browser. And when the user arrives there, a random number is generated. This is done by this Lambda function here. A Lambda function, you can think of it as just a small script, for example, that's using cloud infrastructure to execute. So there's some server in some infrastructure center that executes the script. And so this script that we have here generates a random number. This random number then gets put into a queue, because imagine if this publish function generates a lot of random numbers, then you need a place to store them one after another. And so for that, we have a queue. And then from this queue, the queue tells all subscribers, hey, there's a new random number that has arrived here. Please do something with it. So we have another little script, again, a Lambda function, that picks up each random number and then stores that random number in some persistence layer. So we've chosen DynamoDB, which is a NoSQL database. And every time a new random number arrives, this subscribe function picks it up and puts it into DynamoDB. So you can think of this, for example, in an online store, where users go to your online store, they create an order, then the order gets stored in a queue, and some other sort of function picks up each order, processes the order in some way, and then stores it in your persistence layer. So this is the basic idea about the application that we're going to build. And coming back to what we just talked about, which was the declarative machine language, we're going to write a YAML or JSON file, which encodes all the infrastructure we need. So you can see here, we'll need 2 Lambda functions. We need a DynamoDB. We need a gateway, an API gateway, and we need this queue in the middle. So I've done this in preparation for this talk. So I'll show you what this looks like. For example, if I go to my template file here, there it starts. So it basically starts with a declaration that says resources. And then I'm going to write down line by line, what are the resources that I need? So here I have some queue, I have a layer, I have some Lambda functions, all this stuff. And as you can see in my IDE here, this is actually quite a large file. So it's over 500 lines of code encoded in this YAML style. And what I want to do is, because it's kind of hard to understand what's going on here, I'm going to visualize this. So going back to my browser, I can go to AWS. So here I'm logged into AWS, and the service that I'm using is called CloudFormation, because that's AWS's way of processing these kind of templates. And I'm going to create a new stack. In this new stack, I'm going to upload the YAML template that I've just painstakingly written in my IDE. There it is. And I'm going to look at this in my designer. So the designer is loading. And what I have now, whoops, moving around my components. What I have now is this horribly complicated diagram of interaction. And anyone who has played with cloud infrastructure has probably seen this in one way or another, namely that there are a lot of dependencies. So as an example, down here, I've got my publish Lambda function. Yeah, if I just go back for a moment to my diagram again, we're right here, the publish Lambda function. So this publish Lambda function needs to communicate with the queue. There it is. And here, this is the arrow that connects those two. Now the queue then needs to go over to the subscribe Lambda function, which I have over here in this top right corner. And what's the connection? Well, this arrow apparently is the connection. And then the subscribe function needs to pass information to the DynamoDB table, which I have right here. And all on top of that, in this left quadrant here, I've got this API gateway with different methods. So you can see there are actually a lot of small components and links that need to be established between these components in order to make our app a reality. And so now maybe you're starting to appreciate why this YAML file was over 500 lines long, because all these connections had to be somehow encoded and written down in some big declaration file. So that's basically both the pain point and the advantage that we have now. So we have this declaration file we can write down, but it's still quite complicated. And there's still a lot of manual work I have to do basically in my brain. That's why I have this whiteboard behind me, so I can draw big diagrams with arrows and whatnot and connect all these things and then encode it in some file. But that's not the end of the story, because we're of course talking about an evolution of infrastructure of code. So with having presented this, I will pass back to Max, and he'll show you what might be the next step in abstracting away some of the complication that we see in this diagram.
Yeah, that's right, Maxim. So we have this declarative machine language, which has this very, very specialized structure that should fit exactly on this one cloud provider, like CloudFormation for AWS. But there's not a lot to be done in terms of logic and building logic around this. There's some constructs and workarounds, but in the end, if you need to build your custom logic around this, probably you will need to wrap everything again into shell scripts and so on. So in our mind, the next step in this evolution is a general purpose language, which is still imperative. But the idea is here that all the public cloud providers again provide you with libraries, software development kits that you can use in exactly your programming environment and the programming language that you want. So a notable example here, let's find the right screen, is Bode 3, which is I guess official SDK for using Amazon Web Services in Python. And the way this looks is a bit like this. So this is just Python code, and in Python I can use this library to again interact with the API. Basically, for example, here I'm creating an SQS queue, and this is conceptually very, very close to what I showed you earlier in the CLI. It's imperative again, right? I need to do the imperative steps on my own. And what this implies in particular is that you need to keep track of a lot of stuff. Granted, you can use all the logic and all the control flow mechanisms that are present in your programming language of choice, so in Python a lot, but you need to take care of a lot. So for example, you might want to be a good citizen in your AWS account and not just do an experiment and then, well, I don't care about all of that, the costs don't affect me, but you might want to clean up everything after you are finished with your experiment. It's not so easy here because you have these imperative commands. Okay, here, for example, a queue is created. Just as a demonstration, I added here a second script how I could delete the queue again, and it's not as easy. You see here, the queue is created with some name. So one could hope that you can just delete the queue with the name, but no, it doesn't work like that. In order to delete it, if you're somewhat familiar with Python, I hope you can follow, you first need to list the queues and then filter out the correct queue by its name and then get the URL. And I'm not showing some artificial example that's complicated. I mean, of course, for SQS, it's like this, but it's also like this for other services. For example, here we are deleting a Lambda layer version and I need to make some complicated split to get the correct identifier. So the message is it works in a general purpose language, but it's up to all of the developers to implement the error handling, the state management, and so on. I mean, if I create in an imperative fashion some resource, then it is in some state, and later on I might want to modify it. Then I need to also think about the imperative command that modifies this resource. If I want to delete it again, I need to think about this imperative command. And things could also go wrong in the middle of all of this. Also, what Maxim has pointed out earlier, very often in these contexts, dependencies between different resources are important. And also the developer needs to take care of that manually. I think there's a question. I can't see it. Okay, maybe I get into that while Maxim is talking, if that's fine, then I'm not interrupting myself right now. So then the next step, so the idea is, okay, a lot of people have the same problem, that you need to implement error handling, state management, and so on. And there should be a solution that all of those people could use. And there actually are solutions like this, what we call declarative domain-specific languages.
Max, can I just interrupt you for a second?
Absolutely.
The question I think we should answer is, what makes Bode 3 superior to just plain up using the AWS CLI?
Okay. So in my mind, it's a large advantage to be able to, as I said, use all the convenience features of a high-level language as opposed to just gluing together bash commands, basically. Maxim, do you have something to add?
Mm-hmm. Yeah, so with the CLI, you know, you could write some sort of Python, I mean bash script, I guess, and bash has some limitations, but also with Python, you get all sorts of libraries that you can use, like testing and linting and all sorts of other things. So you get the full power of a general purpose language versus just having, you know, your bash shell basically and some commands you have to execute right away.
Yep. I hope that answers it. If not, Christoph, please ask again. Yeah, so what I was just was trying to say is that the declarative domain-specific languages have emerged. One very important example that we're going to demo in a few seconds is called Terraform. And declarative in this context means that, as opposed to the imperative style we saw in the 2 steps before, where I need to make the exact commands to create something, to modify something, to delete something, I just declare the desired state, more like what Maxim showed you earlier in the declarative machine language model of CloudFormation. And then Terraform will, from your declared desired state, build a directed acyclical graph with all the dependencies and realize all of them in the real world or in your favorite cloud provider. So the way this looks like is the following. So here we have this folder with Terraform files. And actually, let me move that over here a bit. No. Okay, it doesn't seem to work while I'm sharing. Well, let's do it like this. I can just trigger Terraform using the command Terraform apply. What this command does, it will, in this folder, scan through all the files that have the correct file ending. It will build this directed acyclical graph, and it will compare to the actual state that's already present, and then check what is still necessary to realize the desired state. So in this case, it tells us it needs to add 25 resources. So recall all the little components that Maxim showed you earlier in this visual editor. All of them will be created here. So it prompts me whether I'm sure that I want this in a production environment. Of course, we advise to always review this carefully, but now for the slide demo, it's okay. We create something called absolute beadle. And I want to get into the syntax here a little bit. So the way this works is we can create resources of different types. For example, here, an SQS queue, if you remember from the picture that Maxim showed you of the target architecture. And all of these resources have properties that can be specified. So in this example, a name prefix. And Terraform also allows you to codify these dependencies, as I said. So for example, here, an AWS Lambda event source mapping is the part that will later be responsible for forwarding all the SQS messages or events to the Lambda that in the end will write to DynamoDB. So here we can reference stuff. We reference the queue created here, and we also reference a Lambda function that was created in a different file here. And by the way, the IDE support is quite strong. I can just command click in here and will end up in the other file where the Lambda is has been created. Okay, so I was talking way too long. It's already finished some time here. What we want to try now is whether it works actually. So let's find some browser.
Mm-hmm.
I didn't get that, Arvid. Okay, so let's first maybe recall how the infrastructure should look. So we want, how we test this now is very easy. We have this API gateway that exposes an HTTP endpoint to the world. We want to invoke this and then check whether in this DynamoDB table, whether the events end up there. So let's first open up the DynamoDB table. We have this absolute beetle random numbers here. And we see that this is currently empty, so 0 to 0 items. And here in my Terraform output, I had the URL that I can post to. So let me do that, send a message here. And it says I've hit send, successfully pushed message 9281 to queue. So again, recall or appreciate, this message was an output from this publish function, which we exposed via an API gateway. This function produced the message to SQS from where yet another function consumed it and wrote it into DynamoDB. Okay, and I haven't haven't showed you that it really arrives there. Let's refresh here, 9281. I know you could think I was talking so long because it's slow, but that's not true. So I can publish some more, and they arrive here. So it was really easy to build this somewhat complicated infrastructure. And I showed you how complicated it is to tear it down if we were using something like Boto3. Here, the teardown is very, very easy. I didn't give any specific instructions how to tear down here in the Terraform code, but I can just do Terraform destroy. And again, in this case, it's even more advisable to review very carefully in a normal productive environment. But just like that, I'm being a good citizen, and the AWS account is clean again. So Terraform has become somewhat of a standard in this domain, but of course there are other tools. One notable thing that we didn't even write on the slides is Kubernetes, which has gained massive popularity in the last 3-4 years. And Kubernetes also follows a declarative approach where you specify your apps or your workloads in a declarative fashion, your desired state, and then Kubernetes, which is a container orchestration system, goes around in what is called a reconciliation loop and compares the actual state to the desired state and makes it so that everything works as you like it. And yeah, as you have seen, Terraform is this domain-specific language. There's some logic possible, some abstractions, and don't repeat yourself or dry. It's also possible via the use of so-called Terraform modules. So you can pack up cloud resources that belong together into reusable modules and can use them via private Git repositories, but you can also make them public in what is called the Terraform registry, which is basically a repository for shared open source Terraform modules, so that you don't have to solve the same problems that other people have already solved before you. So this sounds all very, very fine and dandy and enables you to work very efficiently with cloud services. But Maxim, there's some space left here. Is there anything that could possibly be improved upon this?
There actually is. However, before we go on, I'd like to get back to some of the questions that have popped up while you were talking, Max.
Great.
So maybe I can summarize them for you. The first question is, why would I possibly be using Boto3, so an imperative general purpose language, over just CloudFormation, meaning declarative? What are the possible advantages that I could have by using that when I already have a declarative language that, like you were showing us,
yes,
takes away a lot of the need for having to worry about dependencies, etc.
That's a great question. So in my mind, I would say that there are very legitimate use cases for using imperative commands. So it depends, of course, on what you want to do, but in some cases, just being able to modify a resource directly instead of having to change what is in your declarative model might be exactly the use case that you crave. What are your thoughts on that, Maxim? Do you agree?
Yeah. The questioner is having a follow-up part here. He's saying, cool. Why would you consider Boto3 being higher level than CloudFormation? So, in our ranking of high level versus low level, we put Boto3 higher than CloudFormation.
I think what we wanted to state by this evolution, which of course could be regarded as opinionated, is that while Boto3 enables you to solve exactly this one problem of deploying infrastructure to AWS, there's a lot lacking in the logic department and in the abstraction department, and all of these things are issues that have already been solved a long time ago in high-level general purpose languages like Python or JavaScript or so on. But of course, we could have also switched this order and have, in this case, we would have stressed more the difference between imperative and declarative.
I think one point we're trying to make here is that these YAML templates are basically the machine language of the cloud. So in machine language, it's very difficult to implement logic directly. That's what some of the higher level abstract languages can do for us more conveniently. And so same with the YAML template, you have to repeat yourself. There are no for loops, no while, nothing. You just have to write line by line what is the infrastructure that you desire. And so in that sense, it's more elementary, more basic than some of the abstractions that a language like Python, in which you can use Boto3, allows you to do.
That's right, yes.
And maybe the second question, Max, why would I be using Terraform, which is also declarative, just to make that really clear again? Why is that kind of declarative domain-specific language better than just using CloudFormation directly?
I mean, one very opinionated point is that CloudFormation YAMLs are just terrible in every sense of the word, I guess, because it's very inconvenient to have them checked into version control and whatever. But the stronger point is probably what you, Maxim, have already told us, that we, at least in our presentation here, we view CloudFormation as kind of the machine language of the cloud, whereas Terraform, I mean, is more of an abstraction across that. So Terraform has this concept of modular providers that enable you to talk to different APIs, for example, AWS or Azure or Kubernetes or whatever, and around this builds an abstraction that's a bit more formidable to work with, I guess. Does that make sense?
I think all these questions, they raise that good point. You know, why wouldn't I want to use the declarative power together with the general purpose features? And that's exactly this last step on our ladder that we're trying to talk about. So if I share my screen here again.
Yeah.
Let's see. Okay. You should be seeing my screen again. Then there is, in fact, one more step which tries to combine both of the advantages. So what we have is we have the declarative part, which basically starts all the way down at the bottom with CloudFormation and these YAML templates that we wrote, and then we added logic and keeping our code dry in the more imperative styles and then domain-specific languages. But there's one more step we can take. Namely, what we can do is we can ask, can we have both the ability to declare parts of our infrastructure, but at the same time also imperatively use for loops, testing, linting, maybe even componentized programming. And this is the highest rank on our ladder at the moment, which in the AWS world is introduced with the so-called CDK, the Cloud Development Kit. So not to be confused with the SDK. The SDK is the Software Development Kit. CDK is the Cloud Development Kit. And the distinction is drawn because the Cloud Development Kit basically speaks directly with AWS CloudFormation and does the declarative part with that, whereas the SDK is the imperative part, the imperative counterplay. It's kind of like yin and yang to that. So maybe before it becomes too abstract, I just want to show you on my command line real briefly how does this look like if I have this CDK installed. So what I would do is let's make a little directory here, Big Tech Day, and what I can do is I can say CDK init, and then I say I want my CDK comes with a sample app, so I'm going to initialize that sample app, and I can choose my language that I prefer. So this is one of the big advantages that I now have with the CDK. I'm no longer restricted to needing to learn the Terraform language, the HCL language. So I could put here Java. In fact, let's just see what's available. If I look at the help, then I should be seeing here which languages are supported. I don't see it. There's too much stuff going on. But I can just tell you that what I can do is that I can choose TypeScript, I can choose Java, I can choose Python. And so for the purpose of this demonstration, I'm just going to use TypeScript. And what this CDK is doing for me now is it's prepping a little app. And as soon as this is done, I'm going to show you how this looks like in my IDE. So if I go into my IDE, it's created a big tech day stack. And what's in it is just inside this constructor. So it's constructing a queue, a topic, and then a subscription. So the queue subscribed to this topic. What's nice now too is that I can write tests. So this is something that certainly was never possible before, and even with Terraform, that's quite difficult to do testing of your code. But because we're now in a general purpose language, we have the ability to also take advantage of all general purpose language features, such as using jest in the TypeScript world to write ourselves some tests. So you can see these tests have already passed, green. But what I really am interested in is what does this look like when I apply this to our initial picture that we had here. So remember, we wanted to build this, and we've already seen the complicated YAML template of 500 plus lines earlier. So what I would like to look at now is how does this look like when I try to do this with the CDK. We've already seen it with Terraform. Now let's look at it with CDK. So here I've prepared this in advance, of course, for presentation with CDK. So once again, we have a class. In this case, it's called the random number stack. And inside this constructor, I'm going to declare all the individual parts that I need to make my application happen. So you can see I'm writing TypeScript code, but there's also a declarative portion to all of this. So for example, I'm saying, give me a queue, new queue, tell me the name of the queue. Or with my Lambda, I have a new Lambda function. And of course, I need to specify runtime. So this Lambda function runs on Node.js 12. And then I need to give it some code. The code lies in the same repository that I'm currently checked into. And I can just, with a few lines, write down my entire Lambda function, any environment variables I want to pass into the function. Then I have the REST API. Now, this is a real shocker when I first saw this. If you've ever played with either YAML template files or Terraform, you'll see that defining a simple REST API often takes hundreds and hundreds of lines of code. Now, with the CDK, I'm able to say new Lambda REST API, pass in a handler, which is this publish Lambda that I defined a few lines earlier, and I'm done. This is it. This is all, folks, just those 3 lines in order to write a REST API. Now, what we're doing here is this is called componentized programming. So underneath Lambda REST API lies a lot of code, but it's all been put together into one component with very few input parameters, like in this case, the handler. And this is similar to, if you're familiar with React, how React has components. So instead of having to define dozens of lines of code to write a simple text field, in React, I can just say, give me a component called text field, and with a few input parameters, I can define exactly what I need without having to repeat myself constantly. Now, since we're in TypeScript, I could even publish all of what I'm writing here on NPM and share it with others, right? So I can take advantage of these online registries where developers can either publish or download components that others have already written. So instead of having to reinvent the wheel every single time, I can write a nice component. Once it does a particular job that maybe I haven't found anywhere else, I can share it very easily. And that's exactly what this is. This Lambda REST API is a component designed for a very specific job that is very easy to use. And this actually is part of the standard API of CDK. So I did not have to download this from NPM. This already comes with the CDK. Now, if you're interested in what are all the available components that CDK can use, there's a documentation. So let's just check this out. If I go to the AWS CDK right here, then I probably should type something like, let's see if I go to REST API. Then, for example, here, I'm right here on the API reference, right? So for API gateway, There are certain APIs I can use, for instance, new API gateway, REST API, and they call these things constructs. So the highest level abstraction in CDK is called a construct. And you can see which constructs are available, for example, the REST API construct, and it'll tell you what are the props that you can pass into this. But, and this is the cool thing for anyone who maybe has experience with things like Chalice or serverless, CDK does not force you to use these higher level constructs. So you can use them if you wish to, but it also has lower level constructs. They call them just structs, which are closer to what Terraform does. You see in Terraform, for each resource that's being created in the cloud, you're going to write one declaration block. Well, in CDK, they're saying, okay, we want that, but on top of that, we want to be able to take individual declaration blocks, combine them into one larger construct. So these constructs, they help you to abstract away some of the difficulty of wiring these individual components together, but you're not forced to. So if you need, for some reason, to get down into the nitty-gritty and really work on the actual one-to-one mapping between resources and declaration blocks, you can. So you can go down to the actual structs and work on that level, or you can combine it with the constructs. That's totally up to you. Going back to our example in the IDE, we've talked at length about this REST API, which conveniently we're now able to define in just 3 lines. The remaining things in order to make our diagram happen are that we need the table, also defined in just 4 lines, and another lambda, namely the subscribe lambda. Okay, so in just about 60 lines here, I was able to do what earlier with my YAML template, I needed 500 plus lines for. Now let's see what happens if I actually deploy this. So this will look similar to what we've already seen with the Terraform example. So if I go in here and I do CDK, let's see, I want to do CDK Diff maybe at first, just to see what's the difference with the stack. I should get an error message because what I've done right now is I haven't specified any credentials with which I want to work. For that, we're using a tool called AWS Vault, but you can ignore that for the moment. So I'm going to do this in the TNG playground account. And if I now hit CDK Diff, it's going to output for me what are all the resources that need to be created. So it's still a long list because what CDK does, it tells me broken down to the struct level, all the resources that need to be deployed. Whereas in my code, I was working with constructs, right? So you don't be surprised that you see more here than what I actually had in the code. What's also nice is that it has this table at the beginning, which tells me all the differences in IAM policy changes that need to be made. Now, if you're new to the cloud, I don't want you to get lost by this, but it's basically just making sure that you have a convenient way to see what are the access management rights that need to change so that you don't accidentally, turn the whole thing public when really it was meant just for a select user group. So once you've done that, then you could do CDK deploy. This is similar to how we saw earlier Terraform apply, basically similar commands. Okay, so with this, let's go back to our slides.
Wait, Maxim, if I may interrupt for a short second. Laszlo has raised another very interesting question asking about the execution semantics of these components. So what he means is, what happens if the CDK deploy is executed twice? Will it spin up the same infrastructure twice, or how will it behave?
Okay, good question. So you saw we also had this command called CDK Diff, which is the same as Terraform plan. So what it does is it goes to the cloud and it checks what are the resources that are already deployed. And if there's no change, if there's no diff, then it will not make a change. This is also known as drift detection, because imagine you might be doing something in your IDE or command line, and while you're working on your code, someone in the cloud is clicking in the UI and changing something, right? So maybe they're completely tearing down the thing that you thought is still there. So this is called drift detection, that all these frameworks, they have a way of determining if something has changed in the cloud while you were busy working on your IDE, for example. So usually Terraform actually at the moment is still better at drift detection than CDK. CDK is catching up. but basically for a lot of services, there is already drift detection also available in CDK. And whenever there is something different, then when you type CDK deploy, the framework will notice, oh, there has been a change, hence I must deploy again, or maybe I don't have to do anything. Do you think that answers the question, Max?
Yeah, great. Thanks for explaining that, Maxim. I think Lasso is also happy with your answer. Thank you.
Okay, very good. So in the last few minutes that we still have here together, I wanted to show one example of how you might take this one step further. And this is what we call infrastructure as code on a Lambda. So the idea basically is this. We had the use case in our recent project that there were people who wanted to work with the cloud and its infrastructure, but they weren't necessarily experts at programming or had the time to learn Terraform or even TypeScript in order to use the CDK or something like that. So what we wanted to do is we wanted to provide a simple way, like for instance, a web application with a form that has parameters. And then once the user enters these parameters, he or she can deploy infrastructure in the cloud. So without needing to know any programming language at all, you can still bring up and tear down infrastructure as you please. So what we thought about is how can we run some of these frameworks? So maybe it's Terraform, maybe it's the CDK on a Lambda function, and have a web application that communicates with this Lambda function to dynamically generate templates. So an example could be something like you have a data engineer who needs to write an ingest job. So maybe they have a database and they want to migrate this database into the cloud. In the past, usually you would have to know Terraform or CDK in order to write such a job. But instead, we thought, well, why can't we just have a form into which the user puts all the information like the name of the database, the IP address, passwords, and so on, and then clicks a button, and that button launches the entire stack so that they don't have to learn a domain-specific language like Terraform or even look at any line of code at all if they don't want to. So what we did here is we installed the CDK on a Lambda. It accepts a template with some variables. Then we pass this template to CloudFormation. That's basically similar to what would happen when you type CDK deploy. And we embedded everything in a web app. So to show you this first, how this looks like when you actually look at this in the browser. Where am I here? That's not the right IDE, sorry. Let's go back here, that's better. Right, I think I'm actually still running this. Yes, I am. Okay, wonderful. So if I go back to my local host, this is how it looks like. So it's just a toy example of how your interface might look like. One thing we've done a lot now. We've played with this picture of the stack that generates a random number. So imagine the variable is now what is the highest random number that I can generate. So I've made a simple form, and me as the sophisticated data engineer that I am, I'm going to reduce the number down to 9,999 as the highest. Then I can click request template, and you should see in the network that there is some sort of API gateway, which now in the preview, if you look at this preview, returns this ugly YAML template from the very beginning of the talk. So there are, again, my 500, well, in this case, it's only 400 lines of YAML code. Yeah, and somewhere in here, there should be my 9,999. There it is, some maximum number of 9,999. So the CDK has just generated for me this YAML template. And now that I have this YAML template in my hand, I can click build stack. And what I'm doing here is I'm going over to CloudFormation and sending this template to CloudFormation. So let's see if it arrived there. So if I go back to my CloudFormation screen, then I see now that I have a random stack 9,999 create in progress, right? So what I've just created is one such stack. But now because I'm in a factory model, I can type any number I wish here, like for example, 9 million billion or whatever. And I can launch these stacks like there ain't gonna be a tomorrow. So let's see, just 100 maybe. Okay, going back to CloudFormation. and updating what's going on here, I now see that I have a whole bunch of stacks that are creating in progress. And each one of them, when I call it, like in the fashion that Max has shown you earlier, will generate a random number, with the highest being the number that's behind here. So this is a very simple example of something that has a lot of potential. So in our case, for example, we also built entire Jupyter notebooks and EMR clusters with this, so that if we have a data scientist, for example, data scientists might not be familiar with a lot of Terraform. They can go to a form like this, and you can imagine there will be options like choosing the computation power of the machine they want to use, maybe the number of nodes in the EMR cluster that they're interested in utilizing. And then all they have to do is press this request and build button, and in no time, basically, they'll be able to go to their AWS account and log into a Jupyter notebook with the required specifications. So we're abstracting away a lot of the need, first of all, to know how AWS works, and B, the need to know domain-specific languages like Terraform. So if you would like to learn more about this, I have actually on my private GitHub account made a small tutorial. There it is. I posted a link on the slides as well, but there's this tutorial here called Cloud App Factory. And if you follow the steps, it'll take you through everything that's needed in order to get your hands dirty at building this kind of thing. And yeah, that's pretty much all I've got. Max, did you have any other questions that have accumulated or things you would like to share?
There's yet another question by Laszlo that just came in. Laszlo is asking, would you say that CDK is essentially an operational interface to manipulate the underlying CloudFormation spec while remaining in your favorite programming language, or is there more to it?
No, that's pretty much it. So that's exactly right. Basically, CDK is all the good stuff of CloudFormation with all the bad stuff removed, right? So everything that always annoyed you about CloudFormation is gone by using the CDK. It's basically a way to interact with CloudFormation while having a layer of your own favorite programming language in between.
That's right. And there's yet another question by Thomas Hafemeister, whether we have any specific experience with Pulumi and can specifically compare this to CDK. I myself haven't dabbled much with Pulumi, to be honest. Maxim, what about you?
Yeah, me neither. So I don't know Pulumi at all. I've written it down here on this slide. One of the advantages of Pulumi is that it's multi-cloud. So you can still use your own favorite programming language, but then you can also deploy multi-cloud. That's of course not possible with the CDK. There are some other frameworks like Troposphere and SparkleFormation. They are also, actually SparkleFormation is multi-cloud, but it's limiting you to needing to use Ruby to write your code, whereas Troposphere is only for AWS, but there you can use Python, right? So these are similar in approach, and they all have some limitations that others do not. I think AWS CDK received a lot of traction and attention just because it's published by AWS. I've heard a lot of developers say to me, hey, have you heard of Pulumi? And that sounds nice, but nobody actually has really tried it, or not many people have anyway.
So I know at least of one colleague who has used it and who has given a short talk internally. Yeah. Thomas, if that's okay for you, I will later contact you in Slack, and maybe I can connect you two, and you can share your experiences.
Mm-hmm. Just to add there, I think I've seen actually people making comments there about internally, so just ask in the Slack for Ye, and maybe you'll find somebody.
Very good.
I would love to use 1 second for a shameless plug. What Maxim has talked to you about using this Lambda to template CDK is actually in production at the BMW group. Of course, not the GitHub repository, but in some other version. If you would like to see that in action, you can join the talk by Josef Vierhauser and myself today in the afternoon at 4:15. Just shamelessly plugging here. Do we have any more time for questions, Arvid?
Sorry, 1 or 2 minutes.
Okay, so is there any sort of integration tests in Cloud Development Kit? meaning tests that both verify infrastructure and, for example, Lambda code.
In TypeScript, you can do whatever you want. So you can use Jest directly on your Lambda code, while at the same time writing other tests that test your cloud infrastructure. So, you know, some of these questions actually come from the fact that we're just not used to anymore writing infrastructure as code in our favorite language, right? So when I first introduced the CDK to some people, they were so astonished that simple things like writing classes and constructors and using Jest to write tests were possible. So I think some of the limitation of our thinking just comes from having used Terraform for too many years.
So just to clarify, of course, you can, in your test assertions, use usual SDK functions and methods just to test, for example, for the existence of cloud infrastructure. That's what you were hinting at, right? Okay. Maybe one final question. Stefan asked, how would you migrate from an existing CloudFormation stack or to CDK without losing everything, in particular stateful things like databases?
Okay, that's a good question. So certainly you can import. Yeah, it's definitely possible to import existing infrastructure into your templates. So there's a function for that within CDK, and in general in CloudFormation that's a function. What is not possible is to migrate a YAML template directly to a CDK, say TypeScript version, because you see that some of these constructs that CDK is using, they are condensed versions of your large YAML template. And so there's no way to automatically take your YAML template and turn it into a nice declarative CDK file. But you can definitely import resources.
And the final question, maybe, I guess we have to disappoint again. Andy wants to know if we have any experience with Troposphere. Myself, I haven't worked with it again. What about you, Maxim?
No, I have not. All I've done is check it out on their website.
Okay, I'm not seeing any more questions here. Should they arise later, please just grab us either in Slack or, yeah, probably in Slack. Arvid,
wonderful.
What else?
Yeah, thank you very much for the interesting talk. I think we're pretty much done here. It would be nice if you could rate the talk or give us some feedback to improve. I'm pretty certain Max and Maxime will be around the whole day in Slack, so if you have further questions, just head out to them. And yeah, thank you for the interesting talk. I haven't seen all of that myself yet, so it was really good to see.
Yeah, cool.
I think Scott wanted to ask some
everyone.
questions, so maybe you can ping him later.
Absolutely. Bye-bye.
Bye.